All right, so here is the review sheet for your test this Thursday, right? So remember, you're going to use this video to help you on problems where you don't know what to do, or maybe you've forgotten a little bit, but again, maybe just watch the beginning of the problem as like a reminder as to what to do, and then finish it on your own and come back and check, or check the answer key in Schoology, okay? You're not going to use this video to like take notes or anything like that. Like, you know, you need to do these problems in your brain so that you know on the test like what to do when this question comes up. All right, so don't use it just to, you know, this is just for your own purposes. You don't want to just like copy me. All right, so anyway, that's my spiel. All right, so here we go. So these words are telling you, or asking you, telling you that this f of x is being changed. F of x is being translated or transformed to this. So what are all the transformations? All right, so look here, this 2. The 2 is different. So that's going to be a stretch, right? It's going to stretch your graph taller than normal, and stretches you up taller. This 3, moving you to the right 3, and then up 4. Okay, remember, inside moves you side to side, and think to yourself, what's the new 0? So 3 minus 3 is 0, so that's why it's to the right. So that's why the graph is now over here at 3. Okay, don't forget, you can also go to your calculator and type this in, all right, just if you want to make sure. So you could actually type in both, like y equals, let me clear my calculator. All right, so you press y equals, you type in x squared. All right, so that's the normal one, and then you go over here, you type in 2 parentheses x minus 3 squared, the square key is right here, plus 4. All right, so you press graph, there's the original, and there is the new one. The new one's a little bit skinnier. It's kind of hard to see because it's up here, but it's a little skinnier, so it's stretched up, and it's moved to the right and up. Okay. All right, over here, this is asking you to find the inverse. Remember this notation right here. So when you write your answer, you're going to write f negative 1 of x, because that's telling me that that's the inverse is. All right, so this is what you do. So remember, to do the inverse, we have to switch the y and the x. So first of all, you need to remember that this is y. So f of x is really the same thing as y. So anytime somebody tells you like g of x or f of x, it's like saying y equals. Just like when we go on our calculator, you know, these are y equals f of x. All right, so I need to switch these letters. So x equals 2y minus 10. Then I'm going to have to solve this for y. So I'm going to add 10. X plus 10 equals 2y. I'm going to divide every single part by 2. So I end up getting my y over here. I get 1/2 with an x on the side, right? Or x over 2, but it's better to write 1/2 x. And this is positive 5. All right, so there's my inverse, 1/2 x plus 5. All right, over here, number 3. So this is pretty similar to the one above it. We're going to write in the words what transformation is done to x squared to get this. So we're going to have a stretch. All right, this is going to move to the left 1 and down 5. Okay, remember, you can always confirm this in your calculator, but we are going to go left 1 and down 5. It puts us right here for our vertex. And from there, our normal parabola would go like this. It would go out 1, up 1, out 2, up 4. But this is getting doubled. So instead of going over 1, up 1, as a normal parabola would do, we're going to go over 1, and we're going to double the 1 to a 2. So we get 2 up on either side. Now normally when you plug in 2, you get 2 squared, which is 4. So instead of going 2 and up 1, 2, 3, 4, I'm going to have to double it like it says. I'm going to double it to 8. So I'm already at 4, so 5, 6, 7, 8 spaces. And I can just match it over here. And that's enough. All right, so draw your parabola nicely. All right, kind of ugly, but whatever. Okay, so over here, we're solving this if possible, so it might be no solution. Let's see. So we gotta clean this up, take away 3. So I have negative 5 with my 2x plus 1 equals negative 15. Divide by negative 5. It goes away. So I have 2x plus 1 equals to 3. All right, so this is fine now. So I take 2x plus 1, set it equal to 3, and I get another answer. 2x plus 1 could equal negative 3, because if you don't know if this is 3 or negative 3, they both make absolute value of them is both 3. So take away 1, so I get 2, and my answer is 1. Take away 1 here, and I get negative 4, so we get negative 2. So I write my solution set is 1 and negative 2, or reversed. All right, over here, I want to go ahead and name some points here. So these are obviously my good points, negative 3, 0, 0, 3, and it looks like 5, 3. Okay, so the inverse. If I have the inverse, it would be 0, negative 3, 3, 0. Remember, we switched the x and the y like we did on number 2, and 3, 5. Okay. All right, and then we're going to graph this up there. So 0, negative 3 will be down here, 3, 0. I'm going to connect those, and then 3, 5. All right, and remember that you can always draw this little horizontal line, not horizontal, sorry, diagonal line. The line y equals x should cut your graph in half, and so it cuts that area, those graphs in half. It's like symmetrical over y equals x. All right, some factoring here. These are perfect squares, so we're going to get x and x. To make a negative 9, I need a plus and a minus, and I split them up 3's. All right, over here, same thing. 2x and 2x, because that makes 4x squared, and plus 5 and minus 5. The reason this works is because this part's negative 10x and positive 10x. These cancel out, leaving me only these two answers. Right, GCF here is a 2, which leaves me x squared minus 4 when I divide a 2 out. So then I keep going, and I do x plus 2 and x minus 2. These have a 3x in common, so I'm going to pull that out, which leaves me x squared minus 16, because 48 divided by 3 is 16. And then I have x plus 4 and x minus 4. Okay. All right, so on the back, some more factoring. We want to factor completely, so we have to be checking for a GCF. So let's see, this guy, these are all even. They all divide by 2. So I'm going to be pulling a 2 out, which makes my life easier. So 2x squared minus 3x minus 14. And then I have to keep factoring. All right, so what makes 2x squared is 2x and x. And I got to pick something that makes 14. So I'm going to try 7 and 2. I can't put a 2 here because 2 goes into 2, and I'm not allowed to put something with a common term there. So I'll try the 7 here and the 2 there, and let's see what happens. I'm going to forget about him. He has to stay there, but I don't even use him anymore. So this is 4x, 7x. Okay, I can make negative 3 from that. Positive 4 minus 7. So minus here, plus there, and we're done. All right, no GCF, so we're just going to start. 3x and x. We're factoring a trinomial here. All right, so look, 5 and 1 is all I need. So I can tell that if I put the 5 here, see how that's going to be 15? And then 1 there, that's going to be 1x, and I can make 14. So 15 minus 1, right? And there we go. I check, it's negative 5, all good. Okay, nothing in common here. So this one's kind of crappy, all right? This 4x squared. I have two possibilities. It could be 2x and 2x, or maybe it's going to be 4x and x. I just don't know. All right, so let's try 5 and 3. So let's put 5 here and 3 there. Let's see what happens. All right, so I think I just lucked out. This is making me a 6x. This is making me a 10x. And that right there can make me a negative 16 if they're both negative. Let's make sure everything's right. So negative and a negative, 2 negatives makes a positive 15. Yep, we got lucky. All right, so if that hadn't worked, I would have maybe tried 15 and 1, but then I would have, if it hadn't worked, I would have just crossed it off and gotten down to this one. So it's this one. All right, 2 goes into all these, so I'll pull that 2 out. Minus 18x plus 32, if I divide them all by 2. All right, so what multiplies to 32 and makes 18? I think I'll be using 16 times 2. So here we go. X and 16 and x and 2. They'd have to both be negative to make a negative 18 and to make a positive 32. All right, these pictures here. Best thing to do for yourself is to fill in these important points. We got negative 2, 4 for the vertex. Okay, we have on the left and going down, so negative infinity, negative infinity. on the right and going down, so it's positive infinity and negative infinity. Okay, domain. So look at your x values. The smallest one is negative infinity, the biggest one is positive infinity. My range, the smallest thing is negative infinity, the biggest thing is 4. It's going down from 4. So negative infinity is first, and then 4 with a bracket. Increasing. So it changes right here. So notice it changes at the number 2. So before 2, the graph is increasing. It has a positive slope. So before 2, before negative 2 that is, and then after negative 2 is increasing. Also, you're just using these x values right here, right? So this area is before 2, this area is after 2. All right, x-intercepts. I got negative 4, 0, and 0, 0. And y-intercept is that one also. So the origin is an x and a y-intercept. As I go to negative infinity, my graph is going down. So see there's that pair right there. As I go to positive infinity, my graph is also going down. And the equation. All right, so let's check. It's going 1, 1, 2, 4. Okay, so that's good. So there's no stretch. So we're just put some parentheses with a square. It's a negative because it's upside down. I have to go right, left 2 and up 4. So x plus 2 and plus 4. There you have it. All right, so square root function over here is going 1, 1 here, 2, 4. There's been no stretch or shrink, so I think I can write my equation. Square root, right 1 up 3, so x minus 1 plus 3. My domain is starting right here at this beginning point, so it's 1 over. My range is from here up, so from 3 up. And there you have it. All right, number 13, write the equation of an absolute value function. So y equals absolute value. It's been transformed by moving the parent function 4 to the left, so x plus 4, 1 unit down, and stretched by a factor of 3, so 3 there. All right, write the equation of a quadratic function. Oops, so this one was called h of x, sorry. This one's called p of x. All right. So quadratic, it's been moved to the right, so I'm going to need parentheses with a square. So it's been moved 2 to the right, so x minus 2, reflected over the x-axis, and compressed. So it wasn't moved up or down. So reflected and then compressed 1/2. So I need a negative 1/2 out there. Okay, last page here. This is just some function work here. So we have 3 different functions named up here. And I have to go ahead and says plug 5 into f. So I'm going to plug 5 in here. So remember, we're replacing the x with 5. So negative 3 parentheses plus 1. So f is the boss, and I'm like, okay, I put whatever I need to right here. So it says I put a 5. So they'll just work it out. Negative 15 plus 1 is negative 14. So there's my answer. So what this also does for you, if you plug in 5 and you get negative 14, this is a point on the graph. Like a point on the graph of this function would be 5 and negative 14. That would be like a location on this line, turns out. All right, so h of negative 4. So I'm going to put negative 4 in both places. So negative 4 here, negative 4 there. Oops, that's a 2. All right, so negative 4 squared is 16. You need the parentheses there. I mean, this is something you could also put in your calculator, but look at the difference. If you do not put the parentheses and you put it in your calculator, you get the wrong answer, because we all know that negative 4 times negative 4 is positive 16. So you have to put the parentheses, please, and you get the correct answer. All right, so minus 8, so this is 8. So that means that there's a point on the graph of negative 4, comma 8, right? That's a point on the graph of this parabola if you wanted to check. All right, so h minus g. So this notation also means just h of x minus g of x. Like, this is more common, but basically, you know, you can write it like this too. All right, so we want to take h of x, so x squared plus 2x, and subtract g of x, which is this one. So 2x plus 6. I'm putting parentheses to protect everything. So these parentheses don't do anything for me. But these ones tell me that the negative gets to everything inside. So it turns into minus 2x and then it turns into a minus 6. So these cancel, so it looks like I get x squared minus 6. All right, f of x times g of x. So I will be taking f of x, which is negative 3x plus 1, multiplying it by 2x plus 6. So this is just a FOILing problem. So multiply these, negative 6x squared. Multiply these, I get negative 18x. Multiply, multiply. Now clean up, negative 6x squared. This is negative 16x, and then plus 6. And there we go. All right, so these last ones, these last three are some composition. So f of g of x. So remember, I have a problem plugged into another problem, so I'm going to get another problem. So f is the boss, so I'm going to write that down. Negative 3 something plus 1. So I'm writing f down, he says, to multiply negative 3 by something and then add 1. So that something is g of x. So let's put this in here. All right, so I got negative 6x minus 18 and the plus 1. So I can put these together. So negative 6x minus 17 is my final answer. Now this next one, I have a number. So whenever you have a number, just figure out this answer. I mean, h of 1. I can just figure out h of 1 right now. So h of 1 is 1 squared plus 2 times 1. So that's 1 plus 2, that's 3. So now you're telling me that this is 3, right? So I'm going to cross this off, and I'm going to say, oh, I'm just finding g of 3. Okay? I'm not going to, like, take this expression and then plug it in up here. Like, that's too much. I figured out that this is 3. So now, put 3 into here. So 2 times 3 plus 6. So 6 plus 6 is 12. Final answer. All right, last one, h. No, so this doesn't say hog. So remember, this means h of g of x. All right, so that means I have to take h. H is the boss. That's this guy. So I have to square something and then add 2 times whatever. So what goes here is g of x. So this goes in both of those places. So 2x plus 6 and 2x plus 6. All right, now, when you see a binomial squared, that means you have to write it twice. So 2x plus 6, 2x plus 6. You can't just like square everything inside. That's not how math works. That's not how like we choose to speak to each other with math, all right? Like if you saw 3 plus 4 and I said square that, well, you would say 7 squared, which is 49. If you did this, 3 squared is 9 plus 4 squared is 16. Does that get you the same answer? No, it does not. So we do not, math is just how we chose to speak to each other. So since you can't add these, you just have to write it twice and multiply it out. Now this one over here, I can just multiply this out now. So plus 4x plus, what, 12. All right, here we go. 2x times 2x is 4x squared. 2x times 6 is plus 12x. Another 12x, and a 36. Plus 4x plus 12. Okay, so 4x squared. That's done. This, and this all go together. So 24 and 4, that's 28x. And 36 and 12, that's 48. So that would be my final answer. All right, that's it. Study your notes, study your homework, look around at some stuff, and try some problems. Bye-bye.